So this is a z-table. This is the reference that tells us the area under the curve between your mean on a standard normal distribution and any z-score that you might calculate on a standard normal distribution. And as it describes up here, we can figure that out by looking up our z-score on the table, and then the area listed is going to be the shaded area here. So the area under the curve between our mean, which will always convert to 0 in a standard normal distribution, and our z-score, whatever we found that to be. And here's how you read the table. Our z-scores are listed in this column here and this row here. And to find a z-score in this table, we're always going to be going out to 2 decimal places. So we'll have 3 digits for whatever z-score we have, and we'll find them listed on this table. So as an example, for a z-score of 2.5, we could write it like this, so we'll just add a 0 here so we have something in this hundredths place in our digit. And we're going to look up our first 2 numbers in the column and our last number in the row. So we'll go down this table and we'll find 2.5, which is our first 2 digits of the z-score, down here in our column. We will then go over on our row, and our last digit here is a 0, so that just means we're looking at this 0 out here, and we're going to look at this column. Where these 2 numbers intersect is the area under the curve between the mean and those values. So the area under the curve between 0 and a z-score of 2.5 on a standard normal distribution is equal to 0.4938. So again, this is a reference that you can use to look up the area under the curve between the mean and different values on any normal distribution, as long as you first convert those values to z-scores. And so we'll be able to use the z-table to figure out the area under the curve between 2 values we're interested in, and that area will be equal to our probability of interest. So let's head back into this example right now. Let's say that what we really want to find, for whatever reason, is the probability of obtaining an outcome between 35 and 75 months in our sentencing distribution. So what are the chances that a person will receive a sentence between 35 and 75 months, or that if you looked at everybody who's been sentenced, you would just so happen to select one person who had had a sentence between 35 and 75 months. So in other words, what are the chances of getting an outcome between 35 and 75 on this distribution that we have here? There are a couple of steps to answer this question, and we've already done one of them. So our first step here was going to be to convert everything to z-scores. We've done that, and we saw that we had a z-score of 1.5 for our value of 35, and a z-score of 2.5 for our value of 75. So step 1, find z-scores. We've done that. And as a reminder, since these 2 distributions are exactly the same, except for the fact that in this one we're counting in months, and in this one we're counting in z-scores, these lines fall in exactly the same place on each one. My own art skills aside here, they should be in exactly the same place, and they should be exactly the same shape. And that means that the area under the curve between these values is equal exactly to the area under the curve between these values. Because again, the only thing that's different is the numbers we're filling in along the x-axis. But the shape of the actual graph itself, the shape of this area under the curve, and the area of this area under the curve are exactly the same in each graph. So the shaded area is the same. Important point, shaded area is the same. So if we want to figure out the area under the curve between 35 and 75, which will answer our question of the probability of getting an outcome between 35 and 75, we could find it on this normal distribution, or we could find it on this standard normal distribution, because this one and this one are exactly the same. And as it turns out, it's much easier to find it on our standard normal distribution, because all we have to do is look it up. And so we have two chunks of this graph that we can look for on our standard normal distribution table. The first one we already found in the example. So the area under the curve between 0 and a z-score of 2.5, which I'm now shading in extra dark here, was equal to this value that we looked up for 2.50 on our z-table. So again, this z-table is a reference that tells you the area under the curve between 0 and some z-score on a standard normal distribution. So it tells us the area under the curve between 0 and a z-score of 2.5 on this standard normal distribution. And this area, as we just looked up, is equal to 0.4938. In other words, 49.38% of the area under the curve can be found between 0 and a z-score of 2.5 going in a positive direction. But how about this other one? We don't have any negative z-scores on this table. As you can see, we start at 0 and we go to about, or we go to 3.4 here. We start at 0 and we go to 0.9. Well, this is a symmetrical distribution. So, as it turns out, you can ignore the negative sign completely because you'd have the exact same area under the curve on either side, whether it's positive or negative. So the z-score for 2.5 or negative 2.5 would give you the exact same area. And a z-score for 1.5 or negative 1.5 would give you the exact same area. So for our other z-score of interest, negative 1.5, we can rewrite it in this 3-digit format. So we'll add this 0 here just to give us a ones place, a tenths place, and a hundredths place. And now we can look up this z-score as well to find the area under the curve between our mean and our z-score of negative 1.5. So again, this 1.5, negative 1.5, we're just going to look up the value for 1.5 and ignore the negative sign, and use that to fill in our area under the curve on this negative side of the graph. So we can look this up. We'll check out our first two digits here. We're going to ignore that negative sign. So we're going to be looking for 1.5 going down the row. And our last digit is 0 once again. So here we'll be still in this column where we have 0 in the hundredths place. And that tells us that our area under the curve for a z-score of negative 1.5 is going to be 0.4332. And so we can come back and add this to our graph here. And now we have two different areas filled in. So on our standard normal distribution, we know that the area under the curve between 0 and a z-score of 2.5 is 0.4938. We know that the area under the curve between 0 and a z-score of negative 1.5 is 0.4332. We also know that the shaded areas on these two graphs are exactly the same. So if we can figure out this total shaded area, we'll know the total shaded area on this one as well. So our total shaded area is going to be equal to the total area that is accounted for by this chunk of the graph and this chunk of the graph. So if we want to figure out our total area, all we have to do is add together this area and this area. So our second step here was to find the area under the curve, where we looked up our values on the z-table. We found that one of them was 0.4938, one of them was 0.4332, and to get our total area, so this total shaded area that corresponds to the probability we're interested in, we're going to add together those two values. And if we do that, so 0.4938 plus 0.4332, we're going to get a total area of 0.927. So our area under the curve between a z-score of negative 1.5 and a z-score of 2.5 is 0.927. The shaded area on our two graphs is the same. That means that our total area under the curve between 35 months and 75 months on this distribution, where we have our units are months instead of z-scores, this total shaded area is also going to be equal to 0.927. So our total shaded area in this one is 0.927. And so our total shaded area in this one is also going to be equal to 0.927. You could also break this down if you wanted. So this chunk of our original graph here is 0.938. This chunk of our original graph over here is 0.4332. But we've already added them together, so we don't need to do that again. And we know that our total area under the curve is equal to this one plus this one, which is 0.927. It's 0.927 on our standard normal distribution, and it means it's also 0.927 on our normal distribution where we're counting in raw scores, so the units we started in, which happen to be sentence lengths in months. So our third step is just to report the probability. The area under the curve between the two values we're interested in is 0.927, and that means that there is a 92.7% chance, or a probability of 0.927, you could write it either way, of getting a sentence between 35 and 75 months. So again, just to sum this up here, our 3 steps for finding this total probability were to convert everything to z-scores, figure out the z-scores for our 2 values of interest, and then look up the area under the curve on the z-table to find out the area between our mean and our z-score of 2.5, our area between our mean and our z-score of negative 1.5. Then we found that total area by adding them together, and that total area was equal to the total area on our original distribution, which was also equal to the probability that we were looking for.